Hey everyone, it's Orkan. Welcome to my channel. Today we are gonna solve LeetCode 62 unique paths problem. The problem statement is that there is a robot on M2N grid, and the robot is initially located at the top left corner, which means here, and the robot tries to move to the bottom left corner, so which means here. And the robot can move either down or right at any point of time, so that each step either it can move right or it can move down. So we are given the two integers m to n, and we need to return the number of possible unique paths that the robot can take to reach the bottom right corner, which means here. So that's our problem. So let's see how we are going to solve it. Okay, let's take actually our previous example and work on it. Let's say that we have a grid m to n. M is equals to 7 and n equals to 3. So it's 1, 2, 3, 4, 5, 6, 7. It's m, and it's m, and the n is 1, 2, and 3. Okay, so first thing is that the robot is located the start. This is the start position, and this is the end position. So we need to find the unique paths that the robot can take to reach the destination. So the algorithm that we are going to use in this case is dynamic programming. So in dynamic programming, we are breaking down to a problem to sub-problems, and first we are solving the sub-problems, then we are using the sub-problems to solve our problem. So in this case, let's actually take that. Let's say that only this grid. Okay, so let's take only this portion. So how many ways that the robot can go to this position? It's only one way. There is only one way it can go, and for this position it's the same. So it can go either right or down. So how about this part? For this part is that for this cell it can either come from this position or come from this position, so which makes it 2. So this is there are 2 ways that the robot can come to this position. So let's actually fill all this with 1, because there is only one way that the robot can come to this position, because it's moving only to the right, and the same here. So there, let's fill the rest of the matrix. So for this position, so how many ways that the robot can come here? So 2 plus 1, then it means 3 ways. So it's 4, because 3 ways from here and the 1 way from here. So it makes it 4. The same with it makes it 5. It makes it 6, and it makes it 7. Okay. So the next, let's move to the next position in the matrix. So how about this one? So there are 3 ways that the robot can come to this position. From 1 from here and the 2 from here, it makes it 3. The same way it makes it 6, because 3 plus 3. So I guess you get the point. So it makes it 10. It makes it 15. It makes it 21, and it makes it 28. So there are 28 ways that the robot can unique path that the robot can take to reach this position. So that's it. That's our algorithm that we are going to use today. So let's put our algorithm to code. Okay, first thing that what we are going to do here, we are going to create a 2-dimensional array. Let's just call it grid, and initialize it. So it's going to be the size of m to n. Okay, so next thing that what we are going to do, we are going to go over our array, our 2-dimensional array, and we are gonna build up our solution. As I said, we are using dynamic programming here. In dynamic programming, we are breaking down our solution to subproblem. First, we start with the subproblem, which we build up to our solution. Okay, for that, we are gonna say that the int I is equals to 0, I is less than m, and incrementing I. So the same what we are gonna do for n. So let's just say j is equals to 0, and the j is less than n, and j, we are incrementing j. Okay, so in this case, what we are gonna say, we're gonna say that the if I is equals to 0 or j is equals to 0, then what we are gonna do, we're gonna say that so in this case, if I equals to 0 or j equals to 0, so it means that we are at the position 0, 1, 0, 2, 0, 3, 0, 4, or 1, 0, 2, 0, 3, 0, and so on. In this position, we are either moving we are either moving from the starting position to the right, or we are moving from the starting position down. So as we have seen also in our explanation part, in that case, the value of our grid is, there is only one way that we can go to those positions. So in that case, I and the j is going to be equal to 1. Okay, is going to be equal to 1. Otherwise, else if they are not equal to 0, then it means that we are at position, let's say that 1, 1. In that case, we say that okay, let's say that we are at position 1, 1, and in that case we can come to that position either from the top or from the left, which means that the 0, 1 and the 1, 0. So for that, we say that the grid I and the j is equals to grid I minus 1, so from the left, j, and plus grid I j minus 1, so from the top. Okay, that's it. Once we exit this loop, so we are solving our subproblem, which eventually leads us to our solution. Once we exit this loop, we are just returning our last value in our grid, which is m minus 1 and n minus 1, and that's it. So let's test our code. All right, so yeah, we did not initialize that here. Okay, great. It works as expected. Let's actually go over it one more time. As I said, we are using dynamic programming here. So dynamic programming is that we are breaking down our solution to subproblem. We are breaking down our solution problem to subproblems, and then we are first solving the subproblem and then building up our solution from those subproblems. So we are initializing two-dimensional array, and we are going over our two-dimensional array, and if the I is equals to 0 or j is equals to 0, then it means that we are moving on the right from the starting position or only down to the starting position. In that case, we are setting because there is only one way we can go to those positions. We are setting the value to 1. Otherwise, we are otherwise, let's say that if it's equals to 1, if at the grid 1, 1, it's the value from the grid 0, 1, and from the grid value from the grid 1, 0, from the left and from the top. That's how we are building up our solution, and at the end we are just returning the last value in our two-dimensional array, which is our which is unique paths that the robot can take to reach the destination. That's it. That's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.